Hello. So today we are going to do this problem, which is part of Leetcode daily challenge. Break palindrome. So the problem says we get a palindrome string that consists only of lowercase English letters, and we wanna replace exactly one character with any lowercase English letters such that the resulting string is not a palindrome, and in that string, the resulting string needs to be the lexicographically smallest ones possible, right? So we want to replace one letter from the string to make it not a palindrome anymore. A string is originally a palindrome, and we want to do it in such a way that we obtain the smallest possible lexicographical one, and we return that resulting string. And if there is no way to make a string not a palindrome, we return an empty string. So you can, for example, one letter A, there is no way to not make it a palindrome, right? So, because even if you replace with any letter, it's still a palindrome since it's a one letter. A palindrome basically is like that the letter reads the same way forward as backwards, right? So that's correct for one letter, no matter what that letter is, right? And here they are just defining what the lexicographically smaller string is, but it's straightforward. It's just like the earlier characters in the alphabets needs to be are smaller than the later ones, pretty much. So if we take a look at this example here, well, we can just replace this B here with an A. That will make this not a palindrome because this B won't match with this with an A here, and here we replace it with the smallest possible character, so that's the smallest one. And you can see here for one letter there is no way to do it, and the maximum length we can have is 1000, so it's pretty reasonable. So let's see how we can solve it. Okay, so how can we solve this? The most straightforward, like sort of brute force way is to just go through the alphabets, right, in lowercase alphabet. So go through basically all alphabets, lowercase alphabet, and basically try to replace every position with a letter, with that letter, right? So first you try A, then you try B, then you try C, then you try D, and so that would be like here you go through every index in the palindrome range, right? And then you try to replace, which means basically you take palindrome at that position and you replace with C, and you check if that is not a palindrome, then basically store it in some best value here, by picking the min, because we want the lexicographically smaller, right? And then just keep going until you hit the end, and then at the end return that string, right? So this would be the brute force way. I'm not writing it completely because it's easy to write, and it's the brute force solution. And this solution will give us, like, here we have 26 letters. Here we have, let's say, length is n. So this would be O of 26n, right? So it's not too bad, right? Especially that n here is up to 1000. Okay? So this is a reasonable solution, but there is an even simpler actually one. So let's look at that one. So what are the different things we can have? So if we have, for a case like this, it's always good to replace the first non-A with an A, right? Because A is the smallest letter, so we'll get the smallest string. So for this case, well, let's just replace B with A. So that would be A, C, C, B, A. And this actually applies to every string that doesn't have all A's, right? Because let's say maybe you have X, X, Y, X, maybe let's say Z here and Z here, so that it's palindrome. Well, the easiest solution is just replace this with an A, replace the first non-A with an A, and you get the smallest lexicographically one, because, well, if you replace A here, that's not smaller. If you replace B here, that's not smaller, right? So it's always better to replace A if you find for the first non-A character, because if you do that, since this is not an A, that means here it's not an A, and that means we'll automatically also make it a non-palindrome, right? Now, the only case that is not covered by this is a palindrome that contains only A's. So like this. For in this scenario, what would be the best solution? Well, in this scenario, the best solution is just to replace the first A with the next smallest character, which is B. So actually not in the front, because if you do it in the front, like BAA is bigger than AAB, right? So it's best to do it for the last character. So to replace this one and end up with AAB. No matter what's the length of A, if you had like AAA, let's say a big number of times, it's always better to replace the last one, because this would be the smallest string, right? And so now the question becomes, how do we implement this? Well, the other thing is to note here is that if you take, let's say AA, let's take this example, ABCA, CBA, right? If we take this example, actually, you don't need to look at these to find the first character, non-A character. You just need to look at the first half, because the first half is the same as the second half, because by definition this is a palindrome, right? So we only need to look at the first half and the first character that is not A replaced with A. If the first half is all A, then we are guaranteed that the second half is all A as well, because this is a palindrome, right? So we only need to look at the first half. And if we do this, so we will just do O(n) divided by 2, so roughly it's O(n) solution, right? Because we do one loop, and as soon as we find the first A, we replace. Otherwise, we replace the last character with B, right? And we are guaranteed if we exit the loop and we didn't find a character different than A, that means the string is, this scenario is all A's, right? Yeah, so that's pretty much the idea. Now let's implement it and make sure it passes test cases. Okay, so let's implement the solution. So here what we need is to go through half of the string, right? So the length of palindrome divided by 2, because that's the same as the last part, so we don't need to look at the last half, right? And then as soon as we find a character that is different than A, we just replace, and that will give us the smallest lexicographical non-palindrome string, because we replace only in the first half, so the last half won't be equal anymore. And so we take the first, we just return it, so we take the first portion, add A, take the last portion, I plus 1. This is actually palindrome here, okay? So what this would mean is basically we replace at position A, right? So everything before I, and then A, and then everything after I plus 1. So we replace at position I. Now, if it's not the case, that means we are in this case where we have some A's, right? And so we return everything except the last character, and in Python we can accomplish that by this one, -1. You could also like do the length of palindrome -1, but we can just in Python just do this. Plus we want to add B at the end, right? To make, and this will make it the smallest non-palindrome, right? Non-palindrome, because this doesn't match anymore, right? But what if it says just a single character, right? Like this. Then or yeah, if it's a single character, we won't enter this loop, because it would be 0, right? And so we won't enter that loop. But here sorry, we will enter that loop with 0, and if the character is different than A, let's say B, we'll replace the character with A, because that's the smallest lexicographical one. Yeah, so if it's the character is just B, then the solution should be A, right? If the character is C, the solution should be A, and that will be accomplished with this loop. But if it's the solution is but A is a palindrome, right? So we shouldn't support it, right? A is not a palindrome, so that's not a valid solution. And here, if we do A and then do B, that's not a valid solution either. So whenever it's one character, we should exit. It's not a valid solution. So what we can do here is we can say only if basically this exists. So we can also do like if length of palindrome is bigger than 1. Otherwise, just return an empty string, right? So with that we can catch it. Let's run this. And here, if we do A, let's do B, just to show you. So those return empty string, right? Because we passed them here. Because we won't enter here. So let me just show you this for A to make sure this is understood. So if we do just B, we won't enter this loop. Print I equal to I. So you can see we don't enter the loop if there is just one element. And so no matter what, for one element, we'll return an empty string. So that's the idea here. Because even if we convert it to A, it's lexicographically smaller, but that's not a palindrome. A is still a palindrome, right? So let's submit. And that passes these cases. And as I said, this is O of n time, right? Because we do at most O of n divided by 2 iterations. And in terms of space, we are not using any extra space, so O of 1. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.